Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Izzy Lawrence. To start our fourth series, we're talking Tyrannosaurus, but we're leaving the king alone. There is no Rex in this episode. Okay, there's a bit of Rex in this episode, but it's the other Tyrannosaurs. Plus, we have comedian Sooz Kempner, who wants to know about Allosaurus. Hello and welcome back to Series 4! My goodness, 4 of Terrible Lizards. And a year ago, we were doing Tyrannosaurus Rex.
Yes, we are opening Series 1, Episode 1. A landmark which surprisingly was followed by Series 1, Episode 2, which is something I wasn't sure was going to happen.
Well, it did. People have enjoyed it. Thank you very much if you're a patron, and thank you very much for leaving us a review and giving us stars and sharing with your friends. You're very lovely people. So, Tyrannosaurus Rex, which is basically the mouth with feet.
Yeah, it's not a million miles away from a description.
I mean, but how many other Tyrannosaurs are there that we know about?
As usual, give or take, because some are controversial as to whether or not they're true species or not. 30, 35?
That's a decent number.
Yeah, it's well above. I think people, if you push them, might go, oh yeah, I'm sure there are others, but they might think there were like 3 or 4 others. And no, they're really quite a major clade of theropods, the carnivorous dinosaurs. And indeed, they're probably a lot more expansive, as it were, in lots of ways than a lot of people give them credit for or would realise. So the oldest tyrannosaurs that we've got are about 160 odd million years old, which meant that tyrannosaurs were around for 100 million years.
Wow, that's long.
It's a fair old whack. I mean, there are other lineages which are going for every bit as long or longer, but they were around a good long time. They are not some last minute popped up, got really big, produced things like T-Rex and vanished again. They were a pretty big group found in Asia, Europe and North America for, the thick end of 100 million years. Not trivial at all. And therefore it's worth having an episode like this talking about not T-Rex, as it were, because of everything else.
Can you explain to me the difference between the different types of carnivorous species? So because obviously Spinosaurus isn't a tyrannosaur and Velociraptor isn't a tyrannosaur. So what's the main thing that makes a tyrannosaur
what defines a tyrannosaur?
Correct, that's the question.
So there are 2 things which are basically universal in tyrannosaurs, and we see these even in the very earliest species, at least as far as we can tell, because obviously some of them are smashed up, etc., etc., etc. The first of which is they have fused nasals. So if you can imagine your average dinosaur, I like to think of a typical dog, so something like a...
I always like to think of a typical dog. That's one of the happy...
But, something, German Shepherdie or Labrador, with really quite a long nose. The equivalent part of the top of that nose, between the eyes and the actual nostrils, the main part of that snout, in dogs and indeed in tyrannosaurs, are nasal bones. They don't really work in us because we've got tiny little nubby ones at the top. And it's a pair, it's one each side. But in tyrannosaurs, they're fused together in the middle and fused to the point that you can't see the joint anymore. We say the suture has obliterated. So basically the bone has remodeled and reworked itself and effectively turned 2 bones into one. I don't know of another dinosaur that does that, but certainly all tyrannosaurs do that.
Does this mean that tyrannosaurs, like dogs, if you put a biscuit on their nose and ask them to wait, they could wait there for a time before flicking it up in the air and going, "Arr"?
I imagine they could, whether or not that's integral to the fusion of the nasals. I'm not sure.
So do dogs have the same thing, or do they have a ridge? I think they've got a ridge, don't they? Or
as far as I know, they're separate bones.
Yeah, I think they've got a ridge. So tyrannosaurs, presumably when they're in the egg, they start as 2 bones and they join into one when they're embryonic.
Yeah, in the same way that, as I think most people know, babies have more bones than adults. That's one of the things. In humans, that's one of the things. Is a lot of the skull bones fused together to the point that you can't see the joints anymore. So tyrannosaurs do that with their nasals. And the other things that they have are what are called D-shaped premaxillary teeth. The premaxilla is the little front bone at the front of the upper jaw, and it has only a few teeth in it. Most teeth are in the maxilla, so premaxilla, it's in front of the maxilla. And they're D-shaped in the sense that if you imagine a capital D, so effectively a semicircle, a flat back with a rounded front. And that is the cross-sectional shape of the front teeth of Tyrannosaurs. So the round bit points forward and the flat bit sits, inside the mouth against the tongue, effectively. And all Tyrannosaurs have this, and they're basically a pair of biting and feeding adaptations. So fusing the nasals up makes the skull really quite strong.
Bone cruncher.
So it strengthens the skull and allows it to take greater forces than you would normally expect for its size. And then the D-shaped premaxillary teeth are a feeding adaptation. And I think we talked about this before, this kind of scrape feeding of putting teeth against something and then pulling the head back. And then using that to strip muscle and stuff off bones. And so, if you find either of those two features, you pretty much know what you have. Nothing else has either of those, let alone both.
Am I right in thinking that humans just have a premaxilla and all the rest is in our ears? Is that right? Of the jawbone?
You're thinking of the lower jaw, not the upper jaw.
Ah, of course I am. That's where I'm going wrong. That's fine.
So mammals as a whole have the mandible, which is the whole of the lower jaw, in mammals is synonymous with the dentary, which is the big bone of the lower jaw, because that's all we have, is we just have a left and right dentary, and they indeed fuse together in the middle and basically obliterate and turn into one bone. But in reptiles, there's 8, 9 bones each side in the lower jaw. There's really quite a few. And then, yes, part of that has become part of the inner ear in mammals, but we're really getting off topic now.
Sorry. Well, we can't talk
it's
about jaws,
it's all good stuff, but it's all lower jaw, not upper jaw. So
fair enough. So upper jaw, they've got roundy teeth at the front, and at the back of the teeth it's all flat, so they can get a good with their tongue, presumably.
They could probably do a good Bugs Bunny impression, yeah.
Yeah, that's
an important part of the evolution of
exactly.
the trade. Those features are basically universal, but the other things that we associate with Tyrannosaurs, or at least that we associate with T-Rex, aren't, which is a lot of the kind of real interest. The ones that are 160 odd million years old, so the middle to late part of the middle Jurassic, so we're going back a fair old way now, they're pretty small. They'd be, waist or chest high to an adult human. They would be fairly normal in terms of their proportions. You would look at them and you wouldn't think of T-Rex. The head was not oversized. The neck wasn't short. The arms weren't short. The legs weren't particularly long. And the head in particular, I mean, it's just a perfectly normal sized head. Indeed, it's quite a small head because they're quite small animals. As you said, head with legs and no arms thing just doesn't exist. And they're also not very big. And so that combination of features is something that actually we have a relatively good idea of that progression. And you can track it through those 30 odd species and basically see tyrannosaurs get bigger and get bigger heads, and the necks shorten and the arms shorten until you get something pretty close to what we're more familiar with.
And this is before dromaeosaurs and things.
Well, they're around right at the same time.
Okay.
So, as usual, we've got these frustrating gaps in the fossil record. The Middle Jurassic, in general, is not very well represented. There's just not many Middle Jurassic rocks with dinosaurs in them available for paleontologists to look at. So the few places we have are really intensely studied. One of which is China, that I've been to. And yeah, there's quite a few things that are appearing in the Middle Jurassic. And the question always then comes is that because that's when those groups actually appeared, or are we just not finding the older ones? Because the Middle Jurassic is a fairly big period of time, and if you can't sample it properly, you're probably going to miss stuff. But certainly the oldest dromaeosaurs and troodontids and possible birds are also from the Middle Jurassic. They're from the very end of the Middle Jurassic, right on the kind of Middle Jurassic, Late Jurassic border, but they are around at that time. So you've got quite a big burst of evolution, because if you look at the standard family tree of theropods, you've got the branch of the origin of the tyrannosaurs, but then you've got compsognathids coming out about the same time, so mostly very small dinosaurs. You've got the ornithomimids, so the ostrich mimics, things like Gallimimus. You've got the oviraptorosaurs, which we talked about before.
We like the oviraptorosaurs.
We've got the therizinosaurs, the giant ones with giant claws that were fat herbivores.
Okay. Oh, yeah, the sickly.
Yep, that's the one, sickle claw ones. You've got the alvarezsaurs, the little anteaters.
Love her.
And then you've also got your dromaeosaurs and troodontids and birds. So you've got 9 major lineages of theropods. All must be appearing some point in the Middle Jurassic. Jurassic. We don't have all of them in the Middle Jurassic, but if the Tyrannosaurs are there and the Dromaeosaurs are there, then everything else in the middle must have evolved somewhere around that time. So even if we haven't found them yet, they're out there somewhere. But yeah, I don't think if we know if the Middle Jurassic is some big boon and burst of evolution, or it's just really, we haven't got a lot of data, so we're probably missing stuff. It's actually quite well spaced out.
That's why we need time machines.
Yeah, but it's a good long time ago. And then, of course, were the Dromaeosaurs present? Yes, though not in these, not in the kind of numbers or diversity that they were later. We didn't have any of the particularly big ones.
So is there, obviously there's a pressure for things to, over millions of years, get a bit bigger. Now, is that because the Dromaeosaurs come in and fulfill the niche better, and therefore it makes sense for a bigger carnivores to start rising up? Or is it for another reason? I nearly managed to finish a question. I nearly did.
There's a general phenomenon called Cope's rule. This was like the first stuff that I did. This was my master's project was on dinosaurs. And Cope was a famous paleontologist. He actually mostly worked on mammals, but he did a fair bit of dinosaur stuff, and he's famous for the Bone Wars of Cope and Marsh, which again was actually mostly about mammals, but everyone remembers it for the dinosaur stuff. And Cope's rule is the idea that over time lineages tend to increase in size. And there's been various arguments and discussions about this in dinosaurs and in other groups. It is generally true, but the question of quite why it's true isn't quite clear, because there are two different phenomena, either of which could be taking place at any given time, and both of which would result in the same thing. One is that big things, on average, have an advantage over small things. So you can imagine, as soon as times start to get a little bit tough, and, for example, there's a bit of a drought and you turn up at the waterhole, if you're the biggest thing there, you are going to be able to bully everyone out, and you're going to make sure you have the best territory and you live in the nicest place and you get the most girls and you get all the water that you want. And those features are going to be inherited, and the next generation is probably, on average, going to be a little bit bigger. And that will tend to ramp up. The flip side of that, though, is that extinction, as we've discussed before, I think, tends to take out bigger things because they require so much more than smaller things, and they're more vulnerable. And if you imagine that a lineage is, there's been an extinction and a lineage is now small, or only small things have survived. Let's just say evolution is random and they could get bigger or smaller. Well, they're already small. So if they go in a random direction, they can't go down very far, but they could potentially go up a very long way. And so on average, and they kind of spread out in an evolutionary sense, they're probably going to get bigger. So
it's a power law.
Either way, you might end up just getting bigger species or getting bigger lineages. And the big question is this kind of passive, i.e. it's just kind of randomly ended up that way because of the environment, or is it active and there's a selective benefit to being big? And some groups are probably one, some groups are probably the other, some groups are probably a combination of it. Working it out is often quite tricky. I would argue with Tyrannosaurs, it's probably active because what we also see is smaller species vanishing. So you don't just see the largest getting bigger and the small ones hang around. We see the largest getting bigger and the smallest getting bigger or going extinct. And that often, I think, is a good indication that you've got probably more of an active trend going on. What probably triggered it, at least partly in Tyrannosaurs, is the Carcharodontosaurs. Now, I don't know if we've talked about them
We
before.
haven't talked about Carcharodontosaurs, but I do like the name, because I'm imagining them picking up cars.
So Carcharodontosaurs is from Carcharodon, which is the scientific name of the great white shark.
Ah!
So these are the shark-toothed dinosaurs, though when I read that, when I was probably an undergraduate, or possibly even doing my PhD, it was like, oh wow, they've got shark teeth, they've got some kind of weird No, they look like the teeth of other theropods, and I really don't know what they were thinking when someone went, oh yeah, shark teeth. They don't look like shark teeth at all. They look like every other theropod that's around at the time. But Carcharodontosaurs are another group of big carnivorous dinosaurs. Carcharodontosaurus itself, one of the bigger ones, big tyrannosaur size, 10, 12 meters plus carnivore. The Carcharodontosaurs are around, in particular, in the early Cretaceous, and they are pretty much the preeminent big carnivore at this point. In North and South America and in Asia, And I don't think we've got any from Europe, but that's probably because we don't have too much of the right rocks. I wouldn't quote me on that, though. I have to check. I don't know my Carcharodontosaurs that well. But anyway, they were like the big one that was everywhere. And then at some point, they really started dying out in the kind of end of the early Cretaceous. And at this point is when you start seeing the Allosaurus, your favourite, taking over in South America, or at least coming to the fore. Carcharodontosaurs hung around, or at least their descendants did, but the Allosaurus really get going. And in Asia and North America, the Tyrannosaurs really get going. So, yeah, the Carcharodontosaurs crashed for some reason, and there's now a niche available for being a really big theropod, and in the Northern Hemisphere, one lot took over. In the Southern Hemisphere, it was another.
So is Allosaurus is not a Tyrannosaur, then? No.
So Allosaurs are a really early branch of theropod evolution, or ultimately are. So Allosaurs ultimately derive from the Ceratosaurs. And they've been around since certainly the early Jurassic. I'm tempted to say late Triassic, but now I try and think of it. I can't think of any late Triassic Ceratosaurs. I think Penn Gillette asked us this as what's the longest lineage? And I think if you trace it through, it would be the Ceratosaurs, because Allosaurs are there at the extinction event, and yet they appeared probably in the early Jurassic.
Wow.
So they were around pretty much the whole of the Jurassic and the whole of the Cretaceous, and were still doing pretty well then, because you had them in Madagascar and in South America in good numbers.
It makes you wonder why they're... I mean, I know why they're not around now, but it makes you wonder why...
Yes, there's one reason in particular.
There's one big skyball reason.
Yes.
But still, it's an interesting thing. It's something that's so successful for that long a time and seeing that much change. Because at the end of the Jurassic, there was a big extinction event. Or there was a significant enough.
Well, there was, so that's one that's kind of... Certainly things go extinct and other things really get going. How big an extinction event it was becomes very hard to say. Because that's the thing, we always talk about the mass extinctions, and obviously there's the one at the end Permian, there's one actually at the end of the Triassic, which really lets the dinosaurs get going, and the one that kills them off. There's lots of others as well. You know, those fairly large extinction events which knock off a significant percentage of species or one continent or one region or whatever, happen in geological terms all the time.
We're going through one now, but it's kind of man-made.
Yeah. But quite how bad and quite how extensive the end Jurassic one was, I think, is really debated. I think it used to be considered much more significant than it is now, for precisely the reason that we're actually talking about, in that it used to be there was this very obvious faunal change where you got into the Cretaceous and the sauropods had all gone, and Carcharodontosaurs and Tyrannosaurs are taking over, and the ceratopsians appear and then go absolutely ballistic, and everyone's like, oh, wow, so all these things died, then all these things appeared, so the extinction. And now we've got ceratopsians and tyrannosaurs and dromaeosaurs and birds into the middle Jurassic. Well, they clearly didn't appear in the early Cretaceous as a result of this alleged extinction event. They'd clearly been knocking around for, anything up to 40, 50 million years at this point, just in very low numbers and tucked away, but they were definitely out there. And so that rather undermines this idea of a big, sudden change. Or at least in terms of the dinosaurs, of that massive flip. Clearly some of that is going on. The ceratopsians really don't diversify into the Cretaceous. The sauropods clearly do take a hit at the end of the Jurassic. But it's not as dramatic, and this sudden new springing up of lots and lots of different groups. Yeah, they're almost all in the Jurassic. I struggle to think of much, actually, which is truly kind of novel in the Cretaceous.
Okay. There's definitely not a sort of big rock hitting the planet at that point.
No, and as someone who doesn't really do extinctions, I don't know what the turnover is largely attributed to. I mean, ultimately, you can boil every extinction event down to some degree of climate change. So probably I'd go for climate change.
That's a good one.
But...
they all got really ugly. That's what happened. Yes. And they just didn't find each other attractive. And the other ones got really pretty. There you go.
Yes. Well, we did that a bit. Was it Robin Ince with the ludicrous extinction theories, which really shouldn't have survived more than 5 seconds thought, because they're so transparently, obviously stupid. That's not much worse than some of them.
Thank you very much. So, Tyrannosaurs then. They're little bitty, looking a lot, in my head anyway, like your dromaeosaurs, but without the sickle, the stabbiness, and just...
Yeah, I mean, if you looked at a small Allosaur or a small Ceratosaur or a small dromaeosaur or even most carnivorous forms of about that size, they, in a general sense, they're much of a muchness. And
like crows and magpies, even though they're the same. That's a really bad example.
Well, they're rather further apart. I'd say something like deer and antelope. Tyrannosaurs evolve from a branch shortly after the Allosaurs. So you can imagine, and Allosaurs really are kind of very generic theropods in that regard, in terms of, they don't have anything particularly exciting going on in any one bit of the body. So perhaps not a surprise that early Tyrannosaurs have the same thing. And then it's only when the Carcharodontosaurs go that they really start getting big. And then that's when we start seeing both the head increase and the arms decrease. So, there's our general assumption basically is that they were stopped from getting any bigger because of the Carcharodontosaurs. And then once those had gone, as I say, you've got this like niche space freeing up. There's room for a big predator, and we're already quite big. So here we go, basically, and they take off.
So we know that T-Rex is massive. So what are the other tyrannosaurs that we should have heard of? And we would be celebrating a lot more if T-Rex didn't exist.
So the most obvious one is Tarbosaurus, which is from Mongolia and possibly down into China and possibly up into Russia. I've heard of bits but never seen anything that confirmed it. And Tarbosaurus is 95% of the size of T-Rex.
Wow.
Very, very nearly as big. Tarbosaurus is occasionally reclassified as a different species of T-Rex. So, or as a different species of Tyrannosaurus. So the normal version of it is Tarbosaurus bata, but that is sometimes called Tyrannosaurus bata, implying that it's a separate species of the same genus. There's only a couple of paleontologists who go for that usage. It's not very common, but it does cause a lot of confusion. Similarly, there's a bunch of teeth from Mexico and some stuff from China and various other bits from the US, which are Tyrannosaurus other species name. But they're always teeth. They're always undiagnostic. There's no particular reason to say that they are definitively Tyrannosaurus, let alone a different species of Tyrannosaurus. Tarbosaurus is the obvious one. Tarbosaurus has slightly smaller arms than T-Rex.
Wow.
Whilst being the same size. Yeah, so the whole, T-Rex has diddy arms. It does, but A, you've got your Abelisaurs, and B, even other giant Tyrannosaurs have smaller arms than T-Rex does. There's a reason that it is sometimes called a separate species of Tyrannosaurus. It basically looks the same. You're down to subtleties in the skeleton to tell them apart.
I mean, we're talking like 95% the same size. I mean, there could be specimens which are larger than T-Rex, and we've only got smaller ones, or...
The suspicion is not, because although very few of them have been described, there's really quite a lot of Tarbosaurus specimens out there. Phil Curry, who's a famous Tyrannosaur researcher and is particularly annoying on this front, keeps telling me just how many Tarbosaurus that he's dug up and found. And I'm like, yes, Phil, but you've written like 2 papers on them in the last 20 years. Could you provide evidence of all this? I'm not suggesting that Phil's lying or that I don't believe him. It's just that, like, they're finding all this stuff and then marking it, or it's just going into warehouses, or the Mongolians are digging it up and storing it and they just haven't done very much with it. And that's often how science goes, but it's very annoying that he keeps telling me just how many there are. No one's ever seen any of it, and nothing's ever been published. But certainly there are quite a few out there, and even the ones that are known and have been described, there's a good number of specimens, and none of them are as big as the 4 or 5 biggest T-Rexes.
Okay.
And so that pretty much suggests that, okay, yes, there's always the chance that we'll find an anomalously big one. But if we've got 20, 30 specimens of each, and we've yet to find a Tarbosaurus which is within, 15% of kind of like the biggest ones, so things like Sue and Scotty, they're almost certainly on average a bit smaller. But still, you are talking about an animal 10 plus meters long and, 5 plus tons. I mean, we're not talking about, wolf and coyote. We're talking about wolf and very slightly smaller wolf. not noticeably smaller.
So there's Tarbosaurus. What other tyrannosaurs are there that we should have heard of, that we would have heard of without?
The other two really big ones. So the first one is Juchang Tyrannus.
Juchang Tyrannus, which you love very much, don't you?
Which was named by half of the people on this podcast. Yeah, so I was the lead author on the paper describing it. Juchang Tyrannus is hilariously incomplete. It's a maxilla and a dentary, so half of the side of the face and half of the lower jaw. That's it. But there's lots of diagnostic traits in there that shows it's quite distinctive. It's about the same size as Tarbosaurus, so a wee bit smaller than T-Rex, but not by very much. There's almost certainly quite a few more bones for Juchang Tyrannus. It's from a quarry in, unsurprisingly, Juchang in eastern China. For anyone who drinks Tsingtao beer, Tsingtao, so Tsingtao is Qingdao. It's an old version of the translation, and Juchang is right outside Qingdao. So the beer factory is like a few miles down the road from the quarry. It really is right on top of it. And yeah, there's several big quarries all next to each other, one of which is full of a giant hadrosaur called Shantungosaurus, which is particularly cool. And in it, they pulled out a bunch of tyrannosaur bones. They pulled out 2 maxillae and they pulled out 2 dentaries, and they're really quite different from each other. So there's almost certainly 2 different species there. The second one, we never really got round to writing the research up on that.
Dave!
That's still a to be confirmed second species. But whatever it is, that second one might be another species that we already know of. It might be something new, but it is not Juchang Tyrannus. And that's the problem, because there's a whole bunch of other bones. There's vertebrae, there's bits of the leg, there's ribs and stuff like this.
I'm just imagining a Lego box that kids mix 3 Lego sets in and you're having to separate them.
Well, that's the problem, is that, and without the instruction. So we know we've got 2 tyrannosaur heads, and we know those are different. And then we've got all these body bits that are isolated. But of course, we don't know which body bit goes with which head. And there's no way of telling them apart.
And is this because they got swirled up in a load of like water and mud or something and mixed about?
Yeah, pretty much. They're all disarticulated and scattered material. So yeah, there's probably quite a lot more than just half a face.
I think if I had a time machine, what I'd do, I'd just go back and I'd just tape a load of dead dinosaurs together. Yeah, just tape them up, or put them in like a sort of like a specific bag, and so they just stay.
Yeah, get some Ziplocs.
Yeah.
Juchang Tyrannus is another giant one, and then we have Daspletosaurus, and Daspletosaurus is rather better known. There's a good number of specimens from
Dasplete.
From Canada. Canada was stuck on the tip of my tongue for some reason. There's a good number of specimens of Daspletosaurus from Canada and from the US. And together, Tarbosaurus, Tyrannosaurus, Juchang Tyrannus, Daspletosaurus, together that is a group called the Tyrannosaurines, or Tyrannosaurinae for their formal name. And these are the truly giant-headed, smallest armed tyrannosaurs out there, and they're all pretty much end of the Cretaceous, last days of the dinosaur kind of era. T-Rex is the last of those. The others are varying degrees a little bit older. Juchang Tyrannus, we actually have a pretty poor understanding of how old it is. Several people have tried to date the quarries and have got wildly different numbers, so no one really knows. Some of the dates put it in the fairly early part of the late Cretaceous. Others put it much closer to the final end, and contemporary then with Tarbosaurus. None of that's been resolved to my knowledge. Periodically, I get sent papers to review on it. Because I wrote stuff on Juchang Tyrannus and Shantungosaurus, editors go, oh, we'll ask him. It's like, yeah, but I know nothing about dating mechanisms at all. Just because I've worked on that quarry, I'm asking the wrong person. So I always turn them down, and then those papers never see the light of day, which suggests that whoever did review them didn't think they were very good or helped the situation very much. So the dating there is a real pain.
All I know is if we've got 5 of these tyrannosaurs, I mean, it's asking for a Spice Girls poster. That is what I'm thinking in my head.
Well, that's where we need. That's where we need to ask Gabriel Agerto, because he's done a beautiful phylogeny. I think you could get it in. I think it was an issue of National Geographic or something, where his phylogeny of all the different tyrannosaurs with a painting of every single one of them was out. It really, really nice. So yeah, that's kind of been done. But yeah, so you could definitely have a Spice Girls of the big five.
So were they all big by the late Cretaceous? The no little ones survived.
So all of these are 10-meter plus animals at adult. So they're all absolute monsters. I mean, bear in mind that, so talking about these earliest ones, and we should go back to them in a bit because there's more to say about them, they're pretty big, because chest high on us.
They're still long.
There's a lot of tail and stuff, you're talking just 1.5 meters high, but probably talking about 4 meters long. These are hefty animals. You certainly wouldn't want to tangle with one. And yeah, they're certainly not tiny.
I mean, the tail and everything, I mean, is it purely for balance and leg muscles, or is there a use for it? I mean, are they doing a diplodocus type? Yeah, do we know how flexible it is, if it's used for anything?
No, they're mostly pretty solid muscle. I mean, for the bipeds at least, you absolutely need a counterbalance, because you are leaning forwards over your centre of mass. You want something at the other end of that to balance it out. And yeah, a big chunk of that tail is taken up with these huge muscles that attach to the back of the leg, pull the leg back, drive the animal forward. So yeah, the tail in tyrannosaurs and indeed theropods in general is absolutely acting as a counterbalance, but it's also a huge thrust thing. They're not super stiff. Some of the abelisaurs have very stiff tails. The dromaeosaurs famously have these extra little bony rods that stiffen them up. I don't think there's anything like that going on in the tyrannosaurs, but they're also not like super flexible, wrap around tight in a knot kind of things. They're really quite, I'm trying to think of a good analogy, maybe something like wet bamboo. There's as in, if you think about it just as a single giant piece, there's quite a bit of flex in it, but there's also a fair bit of stiffness in it.
Yeah. I don't recommend trying to grow your runner beans up a Tyrannosaur, though. I think that would be...
The effort to reward ratio is probably problematic.
I mean, samurai versus T-Rex might be a thing, because they love a bit of wet bamboo to use, cut through.
Oh, for the...
Yeah.
Yeah, but obviously a big T-Rex tail at the base. I mean, I couldn't get my arms around it, so you're...
No, you need a big katana. That's,
Yeah, you want a fairly sizable sword.
Don't do that to T-Rex, it's cruel. This is what I wanted to talk about, because I wanted to go back to the smaller tyrannosaurs that I know nothing about compared to the other ones, and because you mentioned earlier that you wanted to talk about them. So talk to me about the little ones. What's the smallest tyrannosaur that we got?
The smallest that we've got, though, is also a juvenile, so we don't know quite how big it would be, is a thing called Proceratosaurus, because when it was found, it obviously, although it's a single broken skull, it's a really nice skull, actually, just the top kind of snapped off, unfortunately. It's probably a bit bigger than my hand.
But you've got quite beefy paws.
I have got quite big hands, but obviously give you an idea of the kind of size that we're talking about. I
mean, Dave is more of a late Tyrannosaur than an early Tyrannosaur when it comes to humans.
But with normal arm sizes. So skull, 20 centimetres, something like that. And it's got an obvious kind of little bump at the top of its nose, above its nostril, that is turning into a crest, but that's where it's broken off. And we've already mentioned it, there is a famous Jurassic dinosaur called Ceratosaurus. This is from the late Jurassic. This is earlier, this is middle Jurassic, so someone found it and went, Ceratosaurus has a horn on its nose, this has a horn on its nose, it comes before Ceratosaurus, so we will call it Proceratosaurus.
And it's Ceratosaurus.
No, it's not, it's a Tyrannosaur.
This is why we need to have a convention of renaming everything.
Even looking at it at the time, it's like, it really doesn't look much like Ceratosaurus beyond being a theropod. I mean, the fact that it's got half a broken crest on its nose is really not a great reason to do this. But for at least many of our listeners, may come as a surprise, it's British. Proceratosaurus is from the UK.
Woohoo!
In fact, we have two early Tyrannosaurs, because the other one is Eotyrannus from the Isle of Wight. Eotyrannus is much later, much more recent, but still we have two fairly important early tyrannosaurs. So Proceratosaurus is one of the earliest. It's definitely the smallest, but again, it's a juvenile. Quite how much bigger it actually got is uncertain. The earliest one that we've got a good skeleton for and really know a lot about is a thing called Guanlong from the Middle Jurassic of China. So we've got 3 specimens of Guanlong. There is a really nice adult specimen. There's, in some ways, an even better juvenile specimen. And there's the third one, which almost no one knows anything about, because I have to bring this up. I found it, and I'm really, really proud of that fact.
This is where we saw the tip of the tail and found the entire dinosaur. Is that one? Yeah.
Tip of a... it was a bit of vertebra. Yeah, and it not a whole one. There's quite a few bones in there. In fact, in its way, it was disappointingly incomplete, because this is a location in northwestern China called Wusaiwan, and Wusaiwan is famous because it has very, very, very few fossils in it, but when you find them, they're almost inevitably complete and articulated, and there's often multiple specimens together. And so it was very frustrating to find a specimen of Guanlong and actually there's only about a quarter of it there. And you're like, oh, that's annoying. It's actually quite hard in Wusaiwan to find a skeleton and it not be a whole one. But where Guanlong really stands out, and indeed this is where Proceratosaurus and its name comes from. As I said, Proceratosaurus has got this little kind of crest on the nose, but it's kind of broken. Guanlong has the whole thing, and it's this dirty great crest on top of its head, nearly the same size as its head. So it's this long, thin plate which runs almost from the tip of the nose to the back of the head.
So almost like a mohawk.
Yeah, basically almost along the. It's kind of rounded, so it kind of tucks in at both ends to meet the skull. But yeah, it's a massive crest that completely fills the top half of the skull.
Does that make it mean its eye? I mean, because presumably this is a predator and it's trying to make an image with two eyes looking forwards.
It's on top of its head. So if the crest didn't exist, it would have a very, very normal theropod head. Yeah, it's just got a blade stuck along. Again, think of your German Shepherd.
I was thinking it comes down towards the end of its nose, and then it would be able to see. Do you know what I mean? So half of its vision would be a plate coming there, but it's
that's because you're thinking rather human. They've already got their snout between their eyes.
That's true.
So that's already there, and then it's sitting on. Again, think of a dog. You know, if you got a German Shepherd and you make the palm of your hand and put your little finger along the line of its nose, A, that's roughly what this crest looks like, but B, you're really not getting in its vision at all.
Okay.
That's roughly what it's got. That's presumably what Proceratosaurus has got, but has snapped off, and which is why we've only got the front little nub of it. But our interpretation in the light of Guanlong is that Proceratosaurus is a very early tyrannosaur, has this big crest on its head.
And I'm assuming this is pure sexual selection because I can't see an advantage of it, unless it was really bad at it was doing a really bad at focusing thing, or it slept flamingos.
Yeah, it's the obvious thing. It's a big show-off crest on top of the head, particularly for carnivorous dinosaurs. It's not going to be functional in pretty much any other way. So it's going to be some kind of socio-sexual signalling structure.
Unless we find massive leaves which look exactly like that crest, and it was just could wait in a massive bush.
It seems unlikely. So you've roughly got three sets of skulls. So you've got the early things like Proceratosaurus and Guanlong with a big crest on. You've got the later things like the Tyrannosaurines and indeed a couple of groups that come before that, which spikes over the eyes and maybe something going on the nose. And then you've got a few in the middle that have pretty much neither. The obvious example of which is a thing called D-Long, which is another thing from China. And D-Long is certainly the best preserved of the early tyrannosaurs. It's basically complete and articulated and beautiful, beautiful condition. Its head is extremely unornamented. But the thing that everyone knows about D-Long, or the thing that is important about D-Long, it was the first tyrannosaur found with feathers. There's only a couple of patches. There was one from the tail and another one from an indeterminate bit of the body, but they were feathers preserved in situ, attached to the skeleton, intact, in the right place, definitive feathers.
Okay, I want to know, tub feather, are we talking massively long, floofy feathers? Are we talking little warmy, toasty? Are we talking hey, this looks kind of smooth and cool, what we're doing?
Yeah, we're talking little, simple, early feather filaments like you get in modern baby chicks and like we see in various other early feathered dinosaurs.
Ever so slightly floofy.
Yeah, quite possibly.
Just slightly velvety to the touch and not very slick.
I would imagine so, though that sounds slightly pervy the way you said that.
That wasn't I do not perv of the baby bird. You want the textile. As you're being eaten, you want to be able to reach out and a bit of comfort blanket. That's what you want.
I'll stick to not being eaten if that's an available choice. So D-Long was the first one with kind of definitive feathers. So that was obviously really quite an important discovery. And then the last one, which is, in terms of, things people should know, but the one which has become, a cause célèbre really is Tyrannus, which is like the feathered one. And Tyrannus is known, well, definitely from 3 specimens. I think there's probably a couple more now, but in particular, a pair found like tail to tail. So like facing away from each other with the tips of their tails crossing. From beds in Liaoning, so the famous beds that produced all the other famous feathered dinosaurs, exceptional preservation, which allows those feathers to be preserved. 3 specimens of Tyrannus. I've seen a couple of these, and one of them that I saw, I think it was one of the pair, but at the time it was separated from the other one. And I got to see this about 2 years before it was published, and you're like, it's one of those things where people show it to you and they go, you can't tell anyone about this. You're like, Because it wasn't just feathery, it was like feathery from the tip of the snout to the tip of the tail. It was basically an outline around the entire damn thing. This animal was like 7-8 meters long. It's a really big tyrannosaur, ton and a half. And it's just, this complete outline of the whole thing of feathers. And you're like, yeah, that's pretty convincing. Because D-Long had like a couple of bits on the tail, and now it's like head to tail to toe tip.
So I'm thinking big birds from Sesame Street level feathers. Yeah,
I mean, again, simple filaments, pretty big, some of them kind of 15, 20 centimetres. Then, of course, absolutely that's quite big, but on an animal this size.
So more like Snuffleupagus.
Yes. Well, but that's the thing. These things are often drawn shaggy. And, of course, it's like, well, they look shaggy when you find them preserved, but that's because they're all messed up in the water. If you look at things like robins and other birds and they've just come out of the bird bath and they're all fluffed up and wet and they look a complete mess. But once they've preened, it's all super smooth and beautiful looking. And people
talk to me about preening. Would they have been preening these feathers then? Is this...
Well, presumably at some level, because even the biggest birds do that. But of course, lacking the ostrich's... neck and leg flexibility. There are questions about just how well could they keep themselves clean. But then, lots of animals have all kinds of adaptation. You've got things like, Sumatran rhino, to bring this up semi-regularly. It's really quite furry. And rhinos are not well suited to being able to, scratch behind their own ears and on their rump and stuff like this. And they're fine. They don't just get completely matted and covered with parasites and completely unable to groom themselves. Between water and dust baths and
birds,
bit of mutual grooming with other animals and some of that, it's fine. So, yes, I think a big tyrannosaur would have struggled to scratch behind its ears, and there would have been bits of it that it wouldn't be able to reach easily. I don't think that means it would have always, therefore, looked like it had just been pulled through a hedge backwards.
See, I'm just picturing what my cat does every morning on my bed, and I'm thinking that would be amazing. If you woke up in the morning...
Lift its leg up.
Pretty much, yeah. And I'm just imagining a whole field... of D-Long. Exactly, with their legs
D-Long's in better shape because it's much smaller.
That's
and
true.
is not yet at this body plan. Tyrannus is like 2/3 of the way there. The head's pretty big but not giant. The arms are smaller but not tiny. It's got little eye spikes. So it's getting there.
So maybe I'm thinking again about the teeth, and are they good for grooming? Is there anything about it that we can say?
They might be, but you don't say that dogs haven't got anything in particular, and yet they still do that little kind of gnawry thing that they do, when they're going for fleas and stuff like that, and sort themselves out. That you don't necessarily have to have something particularly specialised for this. But yeah, Tyrannus. So Tyrannus was another big step because, again, we'd had D-Long with its feathers, and people had looked at that, and it was like, well, looks like maybe tyrannosaurs are feathered. And the immediate response is, well, these are pretty small, and, the big ones are going to have real problems with heat, and so they're not going to have feathered. And then... well, here's Tyrannus. It's 8 meters long, it weighs over a ton, and it's the featheriest feathered thing that we've ever found feathered.
Floof monster.
Yeah, and so, that again, that's quite an important aspect, because A, it means that D-Long wasn't a one-off. We've now got two, and you've got a much bigger animal, so that adds to that kind of argument that it's not just that it's something more prevalent. It's common in the early taxa.
Before, and I hate to talk about T-Rex, because I know something about T-Rex, but we talked about it before. You said it's possible that T-Rex, some bits of it had some very small feathers on, but you don't believe that was totally feathered.
So this is the stuff with the skin traces that may or may not be scales. There are a number of reported impressions and preserved bits of skin for Tyrannosaurus, Tarbosaurus, Daspletosaurus, and some of the others, which look like they have very scale-like patterns. They have been described as scales. I'm trying to be very careful with my language because I don't want to misrepresent other people or confuse anyone. They have been described as scales. They look like scales. Whether or not they truly are scales is uncertain. Whether or not that rules out feathers being sitting between those scales or being in other parts of the body, I really don't think it does, and I don't think anyone thinks it does. So there is pretty convincing evidence that you have some kind of scaly-like pattern, possibly being true scales, on quite a few bits of various derived tyrannosaurs.
But you can say that about owls' feet. That's not scales.
Yeah, but that doesn't mean that they don't have feathers somewhere. And given that we have things like Tyrannus and D-Long in their ancestry, and given that we have never come across another lineage of birds or dinosaurs which really lost their feathers and, just stripped them out, it does seem unlikely that the big tyrannosaurs completely got rid of them.
Even if they just had, eyelash feathers.
Yeah, so I'm sure they've got something going on. I mean, my personal best guess, and this is little more than some of the literature, a bit of intuition and personal feelings rather than some...
It's not science. We should have a bit of this podcast called This is Dave's Reasoning, not actual science, but based on a lot of very good science.
But that's it. It's exactly that kind of thing, because people voice opinions. I'd call this, an educated and informed opinion. And some people will treat it as absolute fact, and some people will treat it as irrelevant because it's not fact. And it's like, well, it's neither of those things. It's not just a complete guess shot in the dark. But also, no, I can't prove it. My best guess is that tyrannosaurs were at some level fairly scaly. My suspicion is that those are not true scales, and they will eventually turn out to be a weird form of crocodilian type skin that looks scaly but isn't. And I suspect they had lots of little feathers passed out in the little joints and cracks between those. But of course, those aren't going to preserve except under exceptional circumstances, and so we're simply not going to find them until we get something absolutely incredible. And one day I may be proved right, and one day I may be proved wrong, and that's what you wait for the evidence to show you where you should be going with it. But that's what I think things like T-Rex actually probably had.
And what else do we need to know about tyrannosaurs before we have our wonderful special super guest?
I think that's covered a fair bit of it. I mean, the other thing to mention is kind of the plethora of them in North America. So, the real kind of peak diversity. We've got more taxa from Canada and the USA than anywhere else. There's definitely some bits down in Mexico. I'm sure there'll be more coming there sooner rather than later. But some things like Albertosaurus, so we haven't mentioned Albertosaurus, sort of unsurprisingly from Alberta. Albertosaurus is known for something like 50 or 60 specimens now. Many of them are extremely well preserved. It's one of the best known theropods, pretty much full stop at this point. I should say a lot of those specimens are unprepared and, again, sitting in boxes or even sitting in the ground in some cases. But the Royal Tyrrell Museum, where I spent a lot of time, has like 6 or 7 of them are all basically complete and immaculate preservation. Tiny subtleties of the bone. You can just run your fingers over it and feel it. And in particular, there's a bone bed of multiple individual Albertosaurus together, which has been used and often interpreted as evidence for them living in group packs. Yes, and that's why. Yeah, so that's why I left that till last and stopped there, because we want to do an episode on this sort of stuff later. But Albertosaurus is really important from that point of view. really good specimens, lots and lots of data from them, and that bone bed. Though it's not the only one. So there was one just came out a couple of weeks ago, that by the time this comes out, a couple of months ago, as a paper of new specimens of a thing called Teratophonius from Utah. There's another tyrannosaur with evidence of several specimens together in a quarry. And again, same argument was put forward for there. This is probably group living of some description. And Tarbosaurus has been found in groups. We've got Albertosaurus, Tarbosaurus, and Teratophonius at least preserved in, for want of a better description at this point, groups. Certainly multiple specimens together in bone beds which are not obviously a big mix of hundreds of different things.
So not a swirly water drain.
Yeah.
Cool. Well, talking of
swirly water drains?
We have our guest. It's a terrible thing to do. And now joining us over the interwebs is comedian and Twitter mega extraordinary podcaster. She does everything. Her name is Sooz Kempner, and here she is. When we messaged on Twitter, you said you liked dinosaurs when you were a kid, though.
I really loved them, though, as a kid. And it's, you hold on to that knowledge. Also, really loved birds as a kid. Okay. Had that big AA book. Great British Bird Book, I think it's called. And I could name any British bird. And they follow on from dinosaurs, don't they?
Absolutely.
Well, yes. They are.
They are dinosaurs.
Gotcha.
So, yes,
cool.
Quite literally.
What's your favourite tit?
Coal tit.
Okay, that's a good one.
It's got a little hint of pink, which I think is subtle and classy.
Yeah, none of this Robin nonsense.
I like robins.
Yeah, but that's because they're obvious.
They get a lot of press.
And also, they're a bit mean, and they hog my bird feeder, so...
Ooh, it's like having your favourite band as the Beatles. It's like, yeah, obviously, we love Robins, we love the Beatles.
But, yeah, let's
give some love to the Kinks.
More exciting.
So your favourite bird are coal tits and the Kinks.
Yeah.
But do you have a question, though, for Dave? Is there a particular dinosaur thing that you want to get into?
Okay, so when I was a kid, there was a lot of press around the T-Rex, okay?
Well, it's all fallen away and no one talks about it anymore. So I can see why it's drifted. So yeah.
But all I can remember for mid-90s, everyone was into the Tyrannosaurus Rex. No one would talk about the Allosaurus. Okay.
No.
Why do you think it was all T-Rex, no Allosaurus?
See, that's a really cool question. I think we've vaguely touched on this before.
Okay.
There's something nagging at the back of my mind that we've mentioned Allosaurus.
Because I think elegant and just a more sophisticated killer.
They definitely don't get anything like the attention that they should get, and not just in the press, but even in terms of research as well.
Ooh.
Though there was a couple of nice Allosaurus paper just last year. I'm now trying to think back, because obviously the last 18 months is about a week long, or a century, depending on
Yeah. I have no memories of 2019.
Yeah, there was a relatively recent paper describing a new species, which was really quite nice. So yeah, there's quite a lot to say about Allosaurus in that regard. I mean, I think what really did it, going back to your kind of central question, I think what really did it is when T-Rex showed up, it was so much bigger than anything else, because even a big Allosaurus is a fraction of the size of a Tyrannosaurus. And I think it just kind of, Tyrannosaurus just like leapt ahead to such a massive degree. And it was obviously a particularly weird animal.
Yeah.
Because Allosaurus is almost like your quintessential average big carnivorous dinosaur. If you want something that it has some oddities which I want to talk about, but it's like if you wanted to pick something that's just like representative, that's it. It's not got particularly big arms, it's not got a particularly big head, it's not got particularly weird teeth, it's not got a giant long tail or anything like that. It's just like average whilst huge.
Right.
And so I think T-Rex came on the scene and it was so much bigger and with this super giant head and weird little arms and all these other things that I think everyone just kind of leapt on it as the biggest, weirdest, awesomest thing ever.
Okay.
And of course, that's a headline grabber against a backdrop of we've got another big carnivorous dinosaur, but it kind of looks just like all the other big carnivorous dinosaurs.
Gotcha.
But Allosaurus is a weird one where we have an awful lot of specimens, but they're almost all completely disarticulated. Okay. And so we find them in these giant flood quarries where there's bones of Stegosaurus and Diplodocus and Apatosaurus and a whole bunch of other things and Allosaurus. And I want to say there's something like 40 or 50 Allosaurus skeletons out there, which is a hell of a lot for a big carnivore. But I don't think there's any, or at least no good ones with like almost all the bones there, where you could point to it and go, we dug all of that out of one hole and the head was connected to the neck, was connected to the body, was connected to the legs. They're all bits. It's hard, therefore, to sell that as a thing. When you've got some beautiful, big, complete new skeleton, that obviously makes it look exciting and impressive, and you can put it in the museum and say that that's what it is. Whereas we reassembled this from about 70 different bits. Lacks a little bit of that, the kind of cachet, I think, of the big ones.
Because you could get if we all died and got jumbled in a pit, and only some bits of us fought. Imagine like my length of arms on Suze's body with Dave's head. It's going to look odd.
Yeah. Variation is a thing, but it does cause problems for stuff like that. But then kind of going back to the other side of it, Allosaurus is a lot more interesting than people I think often give it credit for, because when you look back at old kids' books, and again stuff particularly from the 70s, 80s, and 90s, Allosaurus was extremely uninteresting. It's like it was just literally quintessential big carnivore, and actually it's got some couple of weird features. Most obviously, it's got a fairly big pair of horns over the eyes and a little ridge that runs down the front of the snout.
Yeah, that's cool.
And this is almost never illustrated anywhere. And it's really prominent and obvious on the better skulls. And yet illustrators just went, nah, we'll just cut them off. I know better than the bones. I'll just get these bits off and draw.
Wow.
And of course, what's happening is they're all just copying each other without looking at the originals. And a lot of the early skulls were bashed up so you don't see it. But it's just this self-perpetuating trope that then completely overlooks the fact that, they've actually got really quite weird heads, which are really quite cool. And no one knows that because you never ever see it. The only one I can think of, there was the recent Jurassic World-like pseudo-trailer thing. So between the last one that came out a couple of years ago and the one that's coming out this year or next year, they made like this little 5-minute short as a kind of keeping everyone going. And it had an Allosaurus in it. And
Is that the one in the trailer park? Or is that
Yeah.
Okay.
Yeah, with the campfire.
I haven't seen it yet.
And they really over-exaggerated the crest, and now it looks absolutely ludicrous and not like any Allosaurus that you've ever seen before. So we've immediately gone from this cut off all the interesting bit of the skull and never show it to dramatically overemphasize it to the point that it looks a bit weird. And you're just like, there is a middle ground. Nice.
Okay, Hollywood.
Yeah.
So is the crests then? Is that what do you reckon that is? Is that to keep sand out their eyes, or is it sexual selection? What's going on? Are they fancy?
I'm at the risk of being boring because I do this all the time. I'd be very surprised if it wasn't some kind of sexual selection and display structure. I
mean, it's Allosaurus. Female Allosaurus must love like that sort of moody, darker kind. They're more sort of emo in their sexual preferences.
Yes, a guy with a strong, heavy brow,
troubled inside, but still snappity snap.
And then gives some shadow. So you've got a bit of dark eyeliner equivalent going on.
It's the dinosaur version of a trilby.
But yeah, I mean they're so thin and fragile. I mean they really are, less than a centimetre thick of bone on a really big, and a really big skull is like nearly 70-80 centimetres long. It's a damn big head, and then that's really quite thin for an animal of that size.
Not using it to fight with then.
Yeah, that's the thing. If they smashed each other, it would snap. If they bit it, it would snap. If it was the classic thing, I've written about this in a bunch of papers. So if it features like this, if it was functional, if it was really doing something like that, you'd expect it to look pretty similar in most other species.
Okay. Fairly
close relative thing called Cryolophosaurus from Antarctica, and literally from continental Antarctica. And that has like a little, like almost like a shell, so as in like the shell logo clamshell, that stuck on the middle of its face, between its eyes. Wow. But that one like points forwards, if you like. So it's like a fan sticking out the front. So, of course, if the Allosaurus crests were like something like shading the eyes from sun, and people have suggested stuff like this, if that was a really important thing for those animals, all its other near relatives should have exactly the same thing, structured in exactly the same way, because that's how it functions. But when they've all got different ones, it's kind of hard to argue that it's a really important, like, mechanical feature when everyone's done it differently. And then it starts to look like something which is almost random. And that's what a lot of display features tend to do, because the function isn't important. It's about having something that's big and weird and novel. So, virtually all pheasants have some kind of weird train and fluff on the head and things like this. But the actual extent of that and quite how they use it and quite where they do it is all varied. It's all over the place. And I think it's basically the same kind of thing here.
Don't compare Allosaurus to pheasants. That's making me think that they'll go after raisins, and you could sew little sleeping pills in all the raisins and catch the Allosaurus and move them where they're not going to get shot. That's a different story.
I want to do this.
Is that Danny Champion of the World?
It is Danny Champion.
I read that when I was about 9. Really straight.
Good story though. That's what, when you say that, I'm now going to picture Allosaurus, sleepy Allosauruses. I mean, what do we know?
Struggle to drag them out.
They were really small. The T-Rex is big, Allosaurus is very small.
Yeah, but they're not that small.
I've learnt this now.
A good size Allosaurus is 9 meters or so long.
Wow.
You're probably looking at a ton and a half.
Oh, so like 2 big horses.
They're not tiny.
So how big was the T-Rex? What sort of size?
So the big T-Rex that we've got, there's a couple which are almost exactly the same size, and they are give or take 13 and a half meters long.
Wow.
And something in the realm of 7 tons plus.
So they were much bulkier, right?
Yeah. So you got to remember mass accelerates much faster than length, because if you're twice as long, you're also twice as tall and twice as wide. So you're 8 times heavier whilst only being twice as long. But obviously that works at all kinds of different scales. So going from 10 meters to 12 meters, it's not a 20% increase. It's like 100% increase at that point. You can virtually double the mass. On top of that, yes, T-Rex is an absolutely barrel-chested, massively built animal. So it's not only longer than all but 2 or 3 other carnivorous dinosaurs, it's heavier built than all of them.
Right. So what are the ones that are bigger?
Well, nothing definitive. And this is where all the arguments always come round, because once you get to bigger and bigger animals, the skeletons inevitably are more and more fragmentary. Yeah. If you're a bigger animal, it's actually harder to bury all of you. And so we don't tend to find it. So there's a couple of things from South America called Giganotosaurus and Mapusaurus.
Ooh.
That's not good names. Giganotosaur, right, but Mapu sounds tiny and cute.
T-Rex that's cool. Yeah.
And then you got Spinosaurus in North Africa.
Oh, but they weren't like a 2 legs one.
Yeah, no, they were. They also. Oh. It was briefly suggested they were quadrupeds, but they.
Oh.
That
mid-90s.
That idea didn't last very long.
Okay.
All 3 of those, and actually a couple of others as well, but let's not worry about them, have been suggested to be longer than a big T-Rex.
Okay.
But none of them are known from even half a skeleton.
Okay.
You're scaling bits of them to try and work out exactly how big they are. And as Izzy was kind of saying, we have real variation. And actually, I've done some papers on tails showing that tails are particularly variable.
Okay.
You can look at this half skull of Mapusaurus and go, actually Giganotosaurus is a better example. You can look at this half skull of that and go, okay, it's closely related to this, and this. They've all got fairly complete skeletons. If we scaled one of them to be the size of this skull, it would be longer than T-Rex. Okay, fine. But maybe it had a really short tail. Maybe it had an unusually long head. Maybe it's doing something weird with its proportions. And so it's actually not quite that big. We don't actually know. And so while
maybe it was just a head in a jar. Who knows?
That's it.
It's just a head with a pair of little legs at the bottom.
Like the Thing.
And it ran around on its tentacles. These are possibilities, if unlikely. there's these names that come back again and again and again as being inverted commas bigger than T-Rex, but they would be longer rather than heavier, and weight is actually a much bigger deal in biology. There are worms that are longer than whales, but no one thinks that blue whales aren't bigger.
Of course. Okay. Yeah.
Weight is the thing anyway, so T-Rex would still be the biggest. And even then, those estimates they're really uncertain. And so it's every bit as likely that they're overestimates as they are underestimates. There's no real guarantee they were actually that big. So T-Rex is basically still definitively the biggest carnivorous dinosaur.
Yeah, I was going to underline the fact we're talking carnivorous. There are bigger others.
Oh, God, yeah. Yeah, once you get into your long neck, long tail sauropods, the big ones are them 70 tons plus.
Wow. Okay. We wouldn't be able to drag one of them out, Izzy, not even between us.
No.
You'd need a lot of people and some rollers, and even then, I'm not sure you're
like building a pyramid.
Pretty much. I mean, think about. That's a couple of buses combined, or a decent-sized aircraft. I mean, it is a.
Wow.
And without wheels. They didn't wear roller skates. If they wore roller skates, maybe that would be a bit easier.
Hard to fathom.
You see pictures of people lying next to a femur of one of these things. So it's just the top bit of their leg, and they're longer than us.
Yeah.
I've got a photo of me doing that with one in Berlin, and the bone's bigger than me, and I'm over 6 foot.
Right.
I'm doing this dance because I want to find out comparative, because it doesn't have the big head, so it doesn't have the little arms either. So what are its front limbs like?
Its arms are really quite big. Again, it is this kind of.
Who knows?
It's like this exemplar thing. So when you think of a relatively large-bodied carnivorous dinosaur, you think of Allosaurus. And it's got fairly long arms. 2 or 3 times the length of T-Rex on an animal that's quite a bit smaller.
Right.
They're relatively well muscled, and they have 3 fingers that are fairly well separated. So in other words, they splay out quite nicely, and they have some pretty big, serious claws on them. I still don't know what those arms do. I still don't think anyone knows what those arms do.
I see.
This is a puzzle that I've been fighting with mentally for about 15 years now, and I haven't solved it, and I don't know anyone else who has. It's really hard to know what they're doing with their arms, because although they're, on the one hand, they're nice and big, and they've got articulations for nice big muscle groups, and they've got these big sharp claws on them. That's the kind you look at them and go, okay, they're obviously doing nasty, grabby, cutty, spiky things with them. But their arms are not ludicrously long. They would still mostly sit under the body, and if they stretched out in front, could just about reach the tip of their mouth. Now, if you're chasing after something and biting it, you want to be able to bite it. You don't want to have to almost overtake it and then try and grab it underneath your chest where you can't see properly.
Sure.
That's a pretty terrible way of grabbing and holding things if you're trying to kill them and eat them for a living.
Yeah.
But it is useful if you want to carry your shopping.
Oh, absolutely.
That's it. We don't think of day-to-day life with dinosaurs, do we?
Exactly. So it could
we always think of the glamorous bits.
So could it be like, I've got to build my nest, I'll pick up these twigs and just carry them back and then dump them in a...
I was thinking it's that particularly blokey thing of you're actually only allowed 1 trip to the car to carry all your shopping. But if you've got 6 claws, you can hang a bag off each one, and then that's 6 bags in one journey.
Yeah, it's good. And then just shut the boot with your elbow. There,
tail.
Car's locked. Or tail. Yeah. Don't even need the elbow if you're dinosaur.
Just bat it down.
So, Sooz, did we answer your dinosaur question? Are you happy knowing a bit more about the Allosaurus?
I am, and I feel like I have so much to learn that I've missed out on over the last 25 years since I went.
This is why we're making this podcast.
That's it. It's perfect.
Well, thank you very much. Do let us know what all the plugs. So you do so many. You go.
Oh, there's too much. Twitter.com/SoozUK, SOOZ UK. Twitch.tv/Sooz Kempner. I'm on 2 podcasts. Mystery on the Rocks is true crime, cocktails and shouting. And the Queen podcast is the official Queen podcast. And we talk about Queen, the band.
Very nice.
That's all the things.
Big thank you to Sooz Kempner. Do check out all of her podcasts. And I think I'm transferred up to the gills. But we're going to do more, you say, on them living in groups and that sort of thing. Yes. Don't just nod at me, Dave. You know how podcasts work by now.
What podcast? You just keep ringing me up to ask me questions.
Oh, for goodness sake. It's lovely to sort of realise how diverse that group is. I personally find, a massive 8-metre long creature or even 10-metre long creature covered in feathers much more interesting than T-Rex in so many ways, just because how terrifying. They're
really, and the Eutyrannus, the main block of this pair of animals, it's an absolutely spectacular specimen. I mean, it's one of those things, because they're both huge and they're both brilliantly preserved, and they're just lying side by side, so with their little tails crossing at the tips. It's quite phenomenal.
It's crying out for a logo.
Yeah, and it's a shame that it hasn't seen the light of day in any particularly big exhibition or anything like that, which is what you really want to see with it. I mean, it's just tucked away in some vault in some random museum in Eastern China, I think, which is more than a bit of a shame, because it's the kind of thing that everyone should cast and stick on the wall of their museum. Yeah. Maybe one day.
One day. Big, furry, scary I mean, this is just going to up your nightmare fuel, isn't it? That sort of, I'm literally dreaming about Snuffleupagus, or whatever his name is.
Snuffleupagus,
there we go. And Big Bird had a baby, and it was called Eutyrannus. All right then, shall we say goodbye, and we'll be back next week. Rawr.
Rawr.
Thank you for listening to the Terrible Lizards podcast, especially if you're a patron. Without you, we wouldn't have made this series. To be the first to hear bonus episodes and get extended interviews, please consider donating at patreon.com/Terrible Lizards. You can find us on Twitter, Facebook and YouTube, so you don't miss out on live broadcasts. All the links are available in the show notes, or go to terriblelizards.co.uk. If you can't afford to support us financially, please do share this episode with your friends and leave us a review on your podcast app. Do say hello via social media or drop us an email, terriblelizardspod@gmail.com. We love hearing from you and we love to answer your dinosaur questions.